Good morning, Dr. Lokman and my fellow friends. We are from Team MindMatters. Our system documentation is the Digital Mental Health Literacy Hub. There are 4 of us in our group, namely Grace Tang Mei En, our leader, Lim Wen Chun, Chong Wei Kang, and Ng Jo En.
Introduction. The purpose. The purpose of this system documentation is to outline all technical and functional requirements needed to guide the development of our platform, which is the Digital Mental Health Literacy Hub. It's designed specifically to help university students to increase emotional awareness and access mental health support. This documentation acts as a core reference for developers, counselors, and academic supervisors. This platform is a cloud-based solution that includes all self-assessment quizzes powered by AI, virtual counseling appointments, anonymous peer forums, and administrative dashboards. It's accessible through both phone, mobile, and desktop, and it integrates with LMS platform via SSO, making it highly usable for both student and staff. We are following Agile methodology supported by the spiral model. This helps us interact, handle risks early, and continuously improve through feedback loops. Each feature is planned and developed incrementally across multiple sprints. Our main stakeholder includes students who are the end users, counselors who deliver the mental health services, administrators managing student wellness data, and also our developer and academic team who ensure the system is built effectively. As of this version, our documentation covers Chapter 1 and Chapter 2, which are the introduction and specific requirements, which consist of persona, system features, launch, phrase, aid user, story details, performance and other requirements, and lastly, design constraints. There are 3 personas in this system that we designed. Each persona includes a specific user need and corresponding user stories that reflect real-life use cases within our platform. The first persona, higher education students, which are the primary user of this platform. Students need a way to learn about mental health, track their emotional state, and seek help quickly. To meet this need, we define 3 user stories. First, the students want to take self-assessment quizzes to better understanding their mental well-being. Second, they want to book virtual counseling sessions to get professional support remotely. And finally, they want to chat anonymously in a peer forum to give and receive support in a safe and non-judgmental space. The second persona is mental health professional that play a key support role in the system. Counselors need to monitor student assessments and deliver virtual counseling sessions. Their user stories include viewing student assessment results to identify those at risk and delivering secure online counseling sessions through video calls. The third persona is academic administrator, who helps manage campus-wide mental health initiatives. Administrators need access to data trends to inform mental health programs and policy. Their user story includes viewing mental health trend dashboards and integrating the system with existing LMS and university portal to ensure seamless across access and central data management.
The use case diagram actor is the student, counselor, and administration, and the main function is that to help users get personalized resource, track mode, and manage the system. The domain model have the 3 key components. The first component is the people, student, and counselor. Second component is the activity, self-assessment, virtual counseling, and the peer forum. The last key component is the system tools, AI contact, analytic dashboard, and get the feedback report. Starting point, the system will log and user is now logged in, and first step is login. And after login, the user become authenticated and sees their dashboard. The main activity is self-assessment part. Start the quiz and get the AI suggestion and read the feedback. Counseling part is book the session, join the session, and counselor take the note. Support tools is user forum, check the mode, and view the analytic. Ending point, user can roll out, system session will time up, process will end.
Product backlog is a to-do list for the development team, and it includes all important features, tasks, and ideas for the system. Each task is written as a user story, and why it is important because it keeps the team organized, alike, and focused on building what matters most. And the key point is clear and complete list of features and tasks, prioritized by sprint, and team member assigned, as well as guide next step. And for our team, the key feature of sprint 1 is registration and self-assessment, and it assigned by Grace and Chong Wei Kang. The second sprint is counseling booking and forum, and it assigned by Joanne and Lim Wen Chun. And the third sprint is admin dashboard and AI content, and it assigned by Lim Wen Chun and Chong Wei Kang. And the last sprint is mood tracking and counselor panel, and it assigned by Grace and Joanne.
I will be presenting the user story 1 self-assessment quiz. This feature is designed for the student to check their mental well-being by taking a simple quiz. And here the basic flow. First, the user will log in and goes to the self-assessment session, complete the quiz, and submit it. Then the system will show the result in the chat or summary, and everything is saved to their profile. To meet the acceptance criteria, the quiz must log properly, result must be clear and visual, data should be saved for the future review. Some condition is the user must be logged in and internet is needed, and if the quiz fails to log, an area will show with a retry option. Step 1, self-assessment. The student will complete the quiz and system generate the result. Step 2, documentation request. The student requests a suggestion and the engine process the request. Step 3, content display. System show the personalizer resource. Student will review the relevance. Step 4, user action. The option is the bookmark and dismiss. Step 5 is error handling. If the engine fail, we'll show the default resource. So step 1 is the user login and login must be successful. And step 2 is navigate to self-assessment module. And step 3 is start and answer the quiz. Step 4 is system check if the quiz can log. If fail, error message show with required option. If successful, results are generated and displayed. Step 5, results are stored in the database for the future review.
The next user story addresses a critical feature of our system, which allows students to book virtual counseling session. The objective is to make mental health support accessible, timely, and confidential by allowing students to connect with a counselor online. The user story ID is US003. It states, as a student, I want to book a virtual counseling session so I can talk to a counselor. The flow begins with selecting a time slot, saving the booking, and notifying both parties. This system ensures the booking is secure, visible in calendars, and avoids scheduling conflicts. The acceptance criteria: time slot is booked exclusively, and booking is saved in calendar. If a slot is already taken, the system prompts the student to choose another date, ensuring there's no overlap. Pre-condition and post-condition. The student must be logged in before making a booking. Once confirmed, the appointment appears in both the student's and counselor's calendar, reflecting the successful end state of this use case. The sequence diagram illustrates the complete process for booking a virtual counseling session. It begins when the student logs into the system, which authenticates the user and confirms access. Once logged in, the student browses available time slots and select a preferred session. The system checks whether the slot is available. If the time slot is available, the booking system confirms the reservation, save the session to database, and send notification to both the students and the counselor. This ensures that both parties are informed of the upcoming session and the booking is securely recorded. If the session is taken, the system enters an exemption flow by prompting the student to choose another time. Once a booking is successfully completed, the session appears in both students' and counselors' schedule and can be viewed through their calendars. This process highlights the system's availability to manage user interaction, prevent conflicts, and maintain real-time synchronization across key components. This activity diagram outlines the workflow involved when a student books a virtual counseling session. It starts with the user logging into the system where their credentials are authenticated. Once successful login, the student navigates to the booking session and views the list available counseling time. The student then selects a preferred time slot, prompting the system to check the counselor's availability. At this decision point, if counselor is not available, the system notifies the student and asks them to choose a different time. This is a part of exemption flow, ensuring scheduling conflicts are avoided. If the counselor is available, the system proceeds to confirm the booking and save the session details. Notifications are sent to both students and the counselor and added to their respective calendars. The final step ensures that both parties can view and manage the session through their synchronized schedules. This diagram effectively captures the main flow, decision logic, and system responses, ensuring a seamless user experience from login to confirm appointment.
The user story file is admin access dashboard. The user story is a student wants to view usage statistics and student mood trends to guide support programs. The flow of event is first admin log in and open dashboard, then view charge on quiz activity, forum usage, and appointment rates, and the last is export reports for internal use. The acceptance criteria is all data is anonymized and report are downloadable. The precondition is admin access required and the post condition is report access or exported. The other condition is data must be seen and anonymized, and the exception flow is if data seen fails, notify the admin with a retry option. The sequence diagram shows how admin access and export reports. It starts with the admin dashboard. From there, they can view usage statistics, export reports, or get seen error alerts when a report is accessed or exported. We make sure all the data is anonymized, then the report are made downloadable, and this keeps user data safe and lets admin get the insight they need. For the activity diagram, show how an admin logs in and gets a report. First, the admin log in. The system checks if they are really an admin. If yes, it shows the dashboard. Next, the system tries to get the latest anonymized data. If it works, the admin can view state and export the report. The report generator matches the file and it is ready to download. If the scene fails, the system shows an error and lets the admin try again.
The next user story is AI-powered content recommendation. User story description. As a student, I want to get mental health resource based on my recent activities. Flow of events. First, system analyze quiz or mood data. Second, suggest content resource. Third, user interacts with or dismiss suggestions. For acceptance criteria, the content should match how the student is feeling. Only safe and easy to access content is shown. Precondition, system must have recent data. Post-condition, interaction are recorded. other conditions, AI algorithms must be running. For exception flow, if AI fails, the system uses fallback suggestions. My left-hand side is sequence diagram for AI-powered content recommendation. First, the student asks the system to get personalized content. The system then sends the student's recent quiz or mood data to the AI engine. The AI engine analyzes this data to figure out what kind of mental health content would be most helpful. Once the suggestions are ready, the AI sends them back to the system. The system then displays the recommendation to the student. The student can choose to bookmark or ignore any of the recommended content. Finally, the system saves the student's response for future improvement and tracking. This sequence diagram ensures that the content a student sees is personalized, timely, and helpful. My right-hand side is activity diagram for AI-powered content recommendation. It starts when the system detects recent activity from the student, like quiz result or mood entries. Then it analyzes that data to understand the student's emotional needs. Based on that analysis, it generates content suggestions like video, article, or tips. These suggestions are then shown to the student on their screen. The student can bookmark the ones that like or skip the ones that don't like. Finally, the system records what the student needs, so it can improve future recommendation. This activity diagram helps the platform become smarter over time while supporting the students' mental wellness. There are 4 performance requirements for the Digital Mental Health Literacy Hub. These are important because they ensure the system runs smoothly, is easy to use, and meets user expectations. The first is response time. All key features like login or submitting a quiz must respond within 3 seconds under normal conditions. The next is throughput. The system should be able to support at least 150 users at once without slowing down. The third is capacity. It needs to manage up to 10,000 registered users, include students, counselors, and administrators. And the last is availability. The system should be available and working 99.5% of the time, with advance notice for any maintenance. There are some other requirements in Digital Mental Health Literacy Hub. The first is usability. It should have a clean and simple interface, work well on mobile phones, and follow accessibility standards so that anyone can use it comfortably. The second is reliability. The system must run smoothly and recover safely from any errors. The third is maintainability. It should be easy for developers to update or fix, thanks to its modular design. The next is portability. The platform must work across all major devices and browsers like Chrome, Safari, Android, and iOS. The next is compatibility. It must integrate with university systems like learning management system and single sign-on logins. For security, user data must be encrypted and protected with role-based access and multi-factor authentication for staff roles. For safety, forums are moderated to block harmful content, and the system will never give medical diagnosis to avoid misuse. For legal compliance, it must follow important privacy laws like GDPR and HIPAA to protect user rights. The last is environmental responsibility. Since it's cloud-based, it should use green data centers and scale resources efficiently to reduce its environmental footprint. Now I will talking about design constraints. Design constraints are like rules or boundaries that we must follow when building our system. There are things we cannot ignore, which is they guide how the system should behave in real life and different devices and under different conditions. There are a few types of constraints. The first is environmental. This means the system should work in different situations, like whether students are using campus Wi-Fi or mobile data at home. For example, it must work even in hot weather or areas with poor internet. The second is hardware. Not all students have the latest phone or laptops, so our system must run smoothly even all older devices like phones with just 2 GB of RAM. The next is security. Because this is about mental health, protecting user data is very important. We must use strong encryption and multi-factor login for sensitive rules. The next is compatibility. The system should connect well with other tools like learning management system and calendars. This makes it easier for users to log in and use the platform. The last constraint is performance. We also want the system to be fast, even when a lot of students are using it at the same time, like during exam or awareness event. These constraints are not just technical stuff, they really matters. They help us keep students' information safe and private, make sure the apps works smoothly anytime and anyway, support easy access even with basic device, and follow legal rules like HIPAA and GDPR.
And that's all from us. Thank you.